Hello, good morning, respected teachers. My name is Manikant Reddy uh, from Cybersecurity Section A. So today I want to explain about uh, power possible generation with nature with high efficiency technology, the subject of chemistry. Okay. First of all, look at about electricity generation. Now, we know that how electricity is important in our life. So we must know about how electricity is generated, what are the sources are there, and what is the possible ways to generate. These are all questions we need to know about that. So first of all, we'll look at about electricity generation. Electricity generation is a process of generating electric power from the sources of primary energy. For utilities in the electric power industry, it is the stage prior to its delivery. One is transmission and distribution, etc. To end users or its shortage using, for example, pumped storage method. Okay. Electricity is not really available in nature. No, electricity is not uh, freely available. Uh, some somewhere we'll get from like a solar or wind or thermal or hydro. From sunlight, we are getting heat, and we are trapping that solar energy through solar panels, and we are converting that energy into electricity. So it is not really available. Somewhere we are converting the energy into one form into another form. Like uh, suppose we are using generators when power cut in our houses or any companies. So generators are the electric machines that convert mechanical energy into electricity. So here fuel is there for generating electricity to generators. Okay, we are using petrol, diesel. These are all fuels. No, fuels are converting into electricity. So electricity is not freely available in nature. So it must be produced. It must be produced. Okay, somewhere we'll not find anywhere in the earth uh, or any air or uh, not freely available. So we must produce, we create that. Okay, that is transforming other forms of energy to electricity. So here I explained already. Here solar energy trapping through solar panels and converting into electricity, and wind energy. Wind energy means we are the kinetic energy of wind. It's converted into other form like electricity. Okay, this and fuels also we are burning it and producing electricity. So production is uh, carried out in a power stations, also power plants. That production where where production is occur, that place is called power stations or power plants. Electricity is the most often generated at power plant by electromechanical generators, primarily driven heat engines fueled by combustion or nuclear fission, but also by other means such as kinetic energy of flowing water and wind. Other energy sources include solar, photovoltaic, and geothermal powers. There are also exotic and speculative methods to recover energy, such as proposed fusion reactor designs, which aim to directly extract energy from intense magnetic fields generated by faster moving charged particles generated by fusion reaction. See, hydrodynamics. Okay. Phasing out a coal-fired power stations and eventually gas-fired power stations are capturing their greenhouse gases. Emissions is an important part of the energy transformation required to limit climate change. Vastly more solar power and wind power is forecast to be required, with electricity demand increasing strongly with further electrification of transport, home, and industry. Okay, day by day, electricity demand is increasing very exponential growth we are seeing because more people are using electricity, more amount of electricity is using, so more electricity is produced. So day by day, the fuels or fuels are exploiting, decreasing day by day. So we are finding ways to produce electricity like with environment. So uh, with nature we are producing with uh, by solar and wind and water and nuclear and geothermal. These are all produced by nature. Okay, we'll see. We'll see the history of what behind this electricity. The fundamental principles of electricity generation were discovered in the 1820s. The principles of electricity generation. How electricity generates, the principles were discovered in 1820s year and early 1830s by British scientists called Michael Faraday. Michael Faraday, his method still using today is electricity to be generated by the moving of a loop or Faraday disk. We'll see that one in airports. We'll see that one uh, starting entry one electric machine is there. When we go into that, uh, somewhere we'll carry any metal thing. That machine produce electricity. That is Michael Faraday discovered that machine. Okay. Central power stations become economically practical with the development of alternating current AC, called AC, power transmissions, using transformers to transmit power at high voltage at with low loss. Okay. Commercially, electricity production started with the coupling the dynamo to hydraulic turbine. The mechanical production of electrical power began the second industrial revolution and made possible several inventions using electricity, with the major contributions being Thomas Alva Edison and Nikola Tesla. Here is the two scientist names. These are main important. Thomas Alva Edison and Nikola Tesla. Previously, the only way to produce electricity was chemical reactions or using battery cells. And the other practical use of electricity was for the telegraph. Okay. Electricity generation at a central power station started in 1882 when a steam engine driving a dynamo at Pearl Street Station production a DC that powered a public lighting on Pearl Street, New York. The new technology was quickly adopted by many cities around the world, which adapted their gas-fueled street lights to electric fuel power. Soon after, electric lights would be used in public buildings, in businesses, and to power public transport such as trams and trains. Okay. Uh, we'll see all these examples. The trains also running by electricity only, and some trains are run with fuel. That fuel convert into electricity also. Here main word behind the machines, all machines are only electricity. Without electricity, no machine will run. The power plants, the first power plant used water power or coal. Today, a variety of energy sources used such as coal, nuclear, natural gases, hydroelectric, and wind and oil, as well as solar energy and tidal power and geothermal sources. In the 1880s, the popularity of electricity grew massively with the introduction of incandescent light bulb. Although there are 22 recognized inventors of the light bulb prior to Joseph Swan and Thomas Edison. Edison and Swan invention became by far the most successful and popular of all. During the early years of 19th century, massive jumps of electrical sciences were made and by lateral 19th century advancement of electrical technology and engineering led to electricity being part of everyday life. With the introduction of many electrical inventions and their implementation into everyday life, the demand of electricity within homes grew dramatically. With the increase in demand, the potential for profit was seen by many entrepreneurs who began investing into electrical systems to eventually create the first electricity public utilities. This process in history is often described as a electrification. Okay? Earliest distribution of electricity came from companies uh, operating independently of one another. The consumer would purchase electricity from a producer, and producer would distribute it through their own power grid. As the technology improved, so did the productivity and efficiency of its generation. Inventions such as steam turbine had a massive impact on the efficiency of electrical generation, but also the economics of generation as well. This conversion of heat energy into mechanical energy was similar to that steam engines. However, at a significantly large scale and far more productively, the improvements of these large scale generation plants were critical to the process of centralized generations, as they would become vital to the entire power systems that we now use today. Throughout the middle of 20th century, many utilities began merging their distribution networks due to economic and efficiency benefits, along with the invention of long-distance power transmission. The coordination of power plants began to form. This system was then secured by regional system operators to ensure stability or reliability. The electrification of homes began in Northern Europe and in the Northern America in 1920 in large cities and urban areas. It wasn't until the 1930 that rural areas saw the large-scale establishment of electrification. Okay. अभी तक we has looked at what is the history of electricity and what is electricity and how what type of methods to generate electricity. Now, actually, what methods of electricity to generate? Okay, we'll look at it. Several fundamental methods exist to convert other forms of energy into electrical energy. Utility scale generations is achieved by rotating electrical generators or by photovoltaic system. A small proportion of electric power distributions by utilities is provided by batteries. Other forms of electricity generation used to Nikkei applications include the turboelectric effect and the piezoelectric effect, the thermoelectric effect, and beta voltaics. Okay, we'll look at this pie chart. 2019 world electricity generation by source. Total generation was 27 petawatts per hour. Okay, most this one black one is coal by electricity generation by coal, and yellow is there. This one is natural gas producing electricity, and blue one is uh, indicated that electricity produced by water, and red one is there. Red one is electricity generated by uh, nuclear. Nuclear means it's type of chemical reactions occur, then only electricity will produce. And green will indicate electricity will generate by wind energy. And this lemon yellow is there. Lemon yellow is indicating the electricity generated by solar. I mean, photovoltaic energy is there. This one. And white means other sources. Other means other than this sources, indicating this white one. Okay. Most of the electricity produced, suppose how 100% of electricity is produced in 2090 year, most 37% of electricity will produce by coal only. Coal is a non-renewable source. Okay, non-renewable source. So it will not renewable, but we are using coal mostly day by day. In 2019 year, 37% of electricity produced by only coal. And second one is natural gas. Most highest percentage natural one is coal, and natural gas is second highest position is there. 24 percentage of electricity in 2019 year will produce uh, the will produce the energy electricity. And what blue one is water, hydro. Electricity produced by water is 16% of electricity, and red one is indicating nuclear, only 10% from this nuclear, and solar 3% of energy uh, will produce from solar, and others from other sources only 5% of energy will produce. And what type of generators? And we'll look at about generators. As we all know, before slides, we are generating electricity. I'm saying about it regularly. Okay. Now, what machines will require to generate electricity? We'll look at about it. That one is called generators. What is generators actually? Any mechanical energy convert into electrical energy. This is called generators. Okay, electrical generators transform kinetic energy into electricity. Okay, this is the most used form from generating electricity and is based on Faraday's law. It can be seen experimentally by rotating a magnet within closed loops of conducting material. Example, copper wire. Almost all commercial electrical generation is done using electromagnetic induction, in which mechanical energy forces a generator to rotate. Electrochemistry. Uh, by using electrochemistry, we will produce electricity. Uh, we'll see. Electrochemistry is a direct transformation of chemical energy into electricity, as in a battery. As same as battery. Electrochemical electricity generation is important in portable and mobile applications. Currently, most chemical powers comes from batteries. Primary cells such as common zinc carbon batteries act as a power sources directly. But secondary cells, rechargeable batteries, will uh, batteries are two types. One is rechargeable and non-rechargeable batteries. Here, primary cells cannot be rechargeable. Secondary cells called rechargeable batteries are used for storaging systems rather than the primary generation systems. Open electrochemical systems known as fuel cells can be used to extract power either from natural fuels or from synthesized fuels. Osmotic power is a possibility at places where salt and fresh water merge. Okay, next one. We'll look at about photovoltaic effect. Photovoltaic effect means we are getting electricity. We are producing electricity from uh, sunlight. How? Through trapping the solar energy by solar panels and converting sunlight energy to electricity. This is called photovoltaic effect. Uh, we'll see more in slide. The photovoltaic effect is a transformation of light into electrical energy, as in solar cells. Solar cells means solar panels. Photovoltaic panels convert sunlight directly to DC electricity. Electricity are two types. One is AC, alternating current, and DC, directing current. Here, photovoltaic panels converting sunlight directly to direct current, electricity. Powers inverters can then convert them to AC, electricity, if needed. Although sunlight is free and abundant. No, is it correct? Sunlight is free, unlimited source is there and abundant. Solar power electricity is still usually more expensive to produce than large-scale mechanically generated power due to cost of a panels. Low efficiency silicon solar cells have been decreasing in the cost. Multi-function cells with a close 30% conversion efficiency are now commercially available in the market. Over 40% efficiency have demonstrated in experimental systems until recently. Photovoltaic were most commonly used in remote sites where there is no access to commercial power grid or as a supplemental electricity source of individual homes and businesses or any offices or like combined with subsidies driven by environmental concerns have dramatically accelerated the deployed of solar panels. Installed capacity is growing by around 20%, 20 per year, led by increases in Germany, countries like Germany, Japan, and US, China, and India. India also producing more amount of electricity. Okay. Actually, this photovoltaic effect, this sunlight converted into electrical energy is eco-friendly process. This one generator is there. There will use the fuels. Fuels will burn very dangerous gases will enter into environment that will poison to us and environment uh, that will should be stopped by uh, by using all these methods such as photovoltaic effect and some processes there. and generating equipment. We'll look at about it. Electric generators were known in a simple forms from the discovery of electromagnetic induction in the 1830s. Uh, in general, some form of prime movers, such as an engine or turbines described above, drives a rotating magnetic field past stationary coils of wire. There will be turning mechanical energy into electricity. The only commercial scale electricity production that doesn't employ a generator is a solar PV turbines. Almost all commercial electrical powers on the earth is generated with a turbine only, driven by a wind, water, or steam, or burning gas. The turbine drives a generator, thus transforming mechanical energy into electrical energy by electromagnetic induction. Electromagnetic induction is a process to convert mechanical energy into electrical energy. There are many different types of methods of developing mechanical energy. Okay, developing a mechanical energy, there are many types of methods are there, including heat engines, hydro, and wind, and tidal power. Most electric generation is driven by heat engines. Okay, the combustion of fossil fuels supplies most of the energy to these engines, with significant fraction from nuclear fission and some from renewable sources. Here, here one doubt: renewable sources. What is mean by renewable sources? It means it we can produce further, or we can produce repeatedly. No, one it is infinity. In example is solar energy. It is a renewable source, and here wind energy is a renewable source. Here one fossil fuels is a non-renewable source. It means fossil fuels will not produce again. So it known as a non-renewable source. The modern steam turbine invented by Sir Charles Parsons in 1884. Steam turbine was discovered by invented by Sir Charles Parsons in 1884 year. Currently generates about 80% of electric power in the world using a variety of heat sources. Here we'll see turbine types include. Uh, Before slide, we learned about turbine. Now, actually, what actually mean turbine and its types? One is steam. One type is steam. Water is boiled by coal, burned in a thermal power plant. About 41% of electricity is generated this way. First of all, water is boiled by using coal uh, in a thermal power plant. About 41% of electricity is generated in this way. Nuclear fission uh, heat created in a nuclear reactor creates steam. Less than 15% of electricity is generated in this way. And renewable energy. The steam is generated by biomass or solar thermal energy or geothermal energy. Okay. And another type is natural gas. Turbines are driven directly by gases produced by a combustion and combined cycles, and driven by both steam and natural gas. They generate power by burning natural gas in a turbine and use residual heat to generate steam. At least 20% of the world electricity is generated by natural gas only. Water energy, and another type is water energy, is captured by water turbines from a movement of water, from falling water, the rise and fall of tides or ocean thermal currents. See, ocean thermal energy conversions. Currently, hydroelectric plants provides approximately 16% of the world's electricity. Okay, the windmills. Windmills means the wind energy captured. was a very early wind turbine. In 2018, around 5% of the world's electricity was produced from the wind. Only wind energy converted into electrical energy is 5% of world electricity. Okay, although turbines are most common in commercial power generations, small generators can be powered by gasoline or diesel engines. These may used for backup generation or as a prime source of power with isolated villages. Now we'll look at about production. How much production is going on? Total worldwide gross production of electricity in 2016 was 25082 TWh. Sources of electricity were coal and peat 38.3%, and natural gas 23.1%, hydroelectric 16.6%, nuclear power 10.4%, oil 3.7%, solar or wind, geothermal, and tidal and others 5%, 5.6%, biomass and waste 2.3% in produce electricity. Uh, Clean sources such as solar and wind and other generated 38% of world's electricity. Here is the graph. Your green color will show renewable source electricity generated through renewable source, and yellow is there. Yellow is nuclear. Nuclear means it's electricity gained by chemical reactions. Here is showing about yellow color, and fossil carbon. Fossil carbon will show this color. This is the graph at annual electricity net generation in the world. Okay, in 1990s, this much is there, and 2010 most highly produced from these no main electricity generation source is renewable source only. And technology. Centralized energy sources are large power plants that produce huge amount of electricity to a large number of consumers. Most power plants use in a centralized generation are thermal power plants, meaning that they use a fuel to heat steam to produce a pressurized gas, which in turn spins a turbine and generates electricity. This is the traditional way of producing energy. This process relies on several forms of technology to produce widespread electricity. These being natural coal and gas and nuclear forms of thermal generation. More recently, solar and wind have become a large scale. Uh, just now we saw a graph. Most of the electricity will produce from renewable source only. No? Here, more recently, solar and wind have become large scale to produce electricity. Solar and wind is a renewable source, and we saw this solar photovoltaic effect in before slide only. Here blue color solar panels which are trapping sunlight and converts into electricity by a controller, and this will trap the sunlight and converts into electricity and sends to controller. Controller will sends to battery. Batteries are there. Batteries for energy storage, and batteries are sends to inverter. Inverter and sends to the electricity to this meter, and meter sends the passes the current to different electric machines like a TV or cooler or a fridge or any laptop. This this is the actual behind these electricity from photovoltaic. Okay, next one. Wind. A wind farm or a wind park, also wind power station or wind power plant, is a group of wind turbines. Here poles is there looking like a poles. Here is called wind turbines. It's the same location is used to produce electricity. Wind farms vary in size from small number of turbines to several hundred wind turbines, converting covering an extensive area. Wind farms can be either onshore or offshore. Okay. Many of the largest operational onshore wind farms are located in China and India and United States. These wind farms are located mostly in India and China and US states. Uh, for example, the largest wind farm in the world is Gansu Wind Farm in China, had capacity of 6,000 megawatts in by 2012. In 2012, in Gansu Wind Farm in China produced 6,000 megawatts with a goal of 20,000 megawatts by 2020. As of December 2020, 1,218 megawatts Hornsea wind farm in UK is the largest offshore wind farm in the world. Individual wind turbine designs continue to increase in power, resulting in a few turbines being needed for the same total output. Okay, thank you. Uh, Thank you so much.